But in terms of what people benefit from, what is right for them, and look, it does raise a good point as to personalised medicine, the future of personalised medicine. We did explore this by looking at the pharmacogenomics of Kava. So we looked at key, what's known as SNPs, the particular genetic differences and polymorphisms related to certain genes, which may influence cavalactone metabolism, as well as the function of the GABA pathway. So we looked at some of these key SNPs to see whether any genetic differences in polymorphisms between individuals taking Kava versus placebo. And originally we did find that there was actually some key genetic differences in what's known as the GABA transporter region. So it's sort of the transporters involved with shuttling a neurochemical known as GABA, which is the main inhibitory neurochemical in the brain, which sort of dampens stimulatory responses, makes us feel relaxed and so forth. So that sort of helps with shuttling the GABA across the neuron, the neuronal wall. And what we did find was that there was originally found to be differences genetically in people's response, but then we just recently did a larger follow-up study, and unfortunately it wasn't replicated. So I'm convinced that obviously there are genetic differences of why people respond to certain medicines, including natural products such as Kava, but we obviously do need to do more work to elucidate what they are.
So assume then that if you don't know as a lead researcher of Kava which genes influence Kava metabolism, or rather how they influence Kava metabolism, these involved genes related to GABA transporting, then neither would the layman who is trying to figure out what his or her genetic predispositions are. So what I'm actually asking is, do you think that there is a use for do-it-yourself pharmacogenetics right now, as of 2020?
Yeah, look, unfortunately for many medicines, many drugs, we're just not quite there yet. There are obviously some good success stories in regards to showing a clear pharmacogenetic influence with a medication. With natural products, really not so much. I mean, probably the only example would be to do with folate, looking at prescription of folic acid, that, depending on the person's, polymorphism to do with the TC677 allele, depending on whether, they're a TT or a TC or a CC, whatever, depending on whether they metabolize the folic acid into an active form, the methylfolate. They're examples of, that's great. You can get tested for that. And if, you're not, you're not a good metabolizer of it, then you can probably look at taking folinic acid or methylfolate, to take it because it's more downstream and get an effect. So that's an example of pharmacogenetics, I think, where it works. Unfortunately, plant medicines are more complex, and to date, to my knowledge, certainly in the field of psychiatry, there's no, clear link with that. I mean, I think we were the first people to do a study on that. We thought, wow, we're onto something. This is really exciting. Yeah. And we got that positive finding, but unfortunately it wasn't replicated. And look, that's not to say that in the future we won't come up with clearer pharmacogenomic answers. Mm-hmm. I think really, what needs to be understood is that, a lot of these disorders, they're polygenic. So it's not just a case of there's a silver bullet polymorphism on a particular, the particular gene, and that's going to be the answer. There's all sorts of different influences of all sorts of genes.